All right, so let's talk about the two classes of receptors. The classes of receptors are dependent on these two things over here. Remember I said we're going to kind of be going through the same thing, right? Okay, we have two major categories of hormones. You know that. We've got lipid soluble and we've got water soluble, right? So when it comes to those two categories of hormones, what they have access to bind to is also determined by their own characteristics, okay? So, next slide. That slide is what I'm talking about, all right? We're going to talk about membrane-bound receptors. So if you have a cell, so here is, let's say, a human cell. One of the things that we talked about was that the tails in that phospholipid bilayer don't like things going through them that have any charge. That's why with the water-soluble hormones, we had to have the fenestrae to let them into and out of the capillary, right? So the chances of something getting into this cell, if it's water-soluble, just aren't really that high. They can't. Like literally, they physically can't because they can't bypass those tails in the phospholipid bilayer. So when we have water-soluble hormones, we have receptors that are membrane bound, okay? So this receptor here is hanging out inside the membrane. Now, the binding site sits outside of the membrane. It's not inside, it's literally outside. Why? Because these water-soluble hormones can only bind to something if it's on the outside of my cell. They literally can't get to anything else. So when we talk about membrane-bound receptors, water-soluble hormones, bind to membrane-bound receptors. That is literally what they bind to. That is the only thing that they can bind to because it's the only thing they have access to. So when I show you that, and I show you a ligand that looks like this, okay, you should automatically say, okay, this is a water-soluble hormone. That's what that is because it's a membrane-bound receptor. It's on the outside, okay? So I'm going to pivot you this way. Hormones that bind to membrane-bound receptors include large molecules. Large molecules won't fit. They won't fit into the cell without destroying the cell, so that makes sense. Water-soluble molecules, again, can't pass through the plasma membrane because the water-hating hydrophobic tails don't like it. So what do we got that are examples? Well, the proteins, big, complex, the glycoproteins, which makes sense because both sugars and proteins have charge. The peptides, which are just short amino acid runs, and smaller molecules like epi and norepi. When the receptor is bound, when this guy is bound, when your G protein coupled receptor is bound, you're going to see a response. So when we talk about the membrane-bound receptors, they're interacting with their receptor, with that binding site outside of our cell. It's on the surface of our cell. It's not going to be inside, it's going to be on the outside. So that type of receptor, our G protein coupled receptor with our little minions, that's going to be a transmembrane receptor because it goes across the membrane. Okay? Now, the second type that we're going to talk about are intracellular receptors. Intra means inside. So these are inside the cell. Out of these two, who can get past the cell membrane with no issue? Our lipids. Our lipid-soluble hormones can bypass a membrane, no problem. So here I've got membrane bound. Here's my cell, right? Let's do that. And here's my receptor inside of my cell, right? So when we talk about an intracellular receptor, that's what this is. Intra means inside. So in order for this to get bound to, whatever's coming has to get past that plasma membrane. In this case, lipid-soluble hormones can. They don't have that stop of, oh no, I don't like you, with the tails. So they just go. So when we talk about the intracellular receptors and we talk about what is going to use that, literally, it's the lipid-soluble hormones. Okay? I'm going to flip this way again. So these include lipid-soluble and relatively small hormones. If you're small enough to sneak by and nobody sees you, okay? So thyroid hormones are examples of this. Steroid hormones, the testosterone, the estrogen, the progesterone, aldosterone, cortisol. They diffuse through the plasma membrane. They go inside the cell through the plasma membrane. And the intracellular receptor, this little dude right here, is waiting for them. Now, something that's kind of interesting about intracellular receptors, they can be in the cytoplasm, but they can also be in the nucleus. So literally, in the nucleus, they can just, okay, I'm going to start making myself a protein. And they literally just go and start reading the DNA, making an mRNA transcript. Now, because of that, because they can do that, it basically means that the hormone receptor complex, the hormone bound to its receptor, can literally interact with the DNA directly, which is kind of interesting. Okay, so now you don't have to see me anymore.